Over to you, Vardaan, my colleague at Womanium, leading the Quantum Solutions Launchpad.
Yeah, good morning, good evening, wherever you are. Welcome to the session. Like Maru mentioned, this is day 3 of the Womanium Quantum Plus AI 2024 program. We will kickstart today's session with a session with Laurentiu Nita, who is the founder and CEO of Quarks Interactive, a very, very exciting game platform where you can learn how to design quantum algorithms in a very fun way. So after that, we will move on to continuing the Q-Bronze lectures, which you have been doing for the 2 past days. We will again have Dr. Gibran and Dr. Claudia again with us to tell you all about Q-Bronze. There will also be a hands-on interactive lab session, which will be hosted by Claudia. So stay tuned for that. All your questions are welcome. I will be moderating today's session. And then tomorrow, we have a keynote session by Dr. William Oliver from MIT and his student Shantanu Jha from MIT as well. We will also have a virtual lab tour at MIT, so very exciting news over there. Followed by continuation of Q-Bronze with an introduction to Grover's algorithm by none other than Dr. Erika Sturm, one of our Womanium QSL fellows. So I'm very personally excited for that too. But yeah, starting today's day, if we can quickly spotlight Laura into the meeting. So quick introduction about Laurentiu. He is the founder and CEO of Quarks Interactive. And the first time I met him, he explained Quarks Interactive and Quantum Odyssey as, this is the gaming platform where anyone and everyone can learn how to design quantum algorithms while having fun. So this is huge, right? Irrespective of what your background is, whether you're a high school student or you are recently getting started into quantum, I think this is the perfect platform for you to understand quantum algorithms without necessarily going into the mathematics and the computer science jargon of it all. So I'll let you take it over from here, Laura, and hope you guys have fun.
Thank you, Vardaan. Hello, everybody. Okay, now I can see myself. I'm way too close. Sorry for that. It took me about 5 years to make this piece of software together with some brilliant programmers, brilliant educators, science educators, and brilliant quantum computing physicists from all over the world. It's reaching maturity. This means that very soon we will be able to say we've done everything you can actually to create a learning platform that's so immersive and so impactful that you'll just find yourself spending time as if you're spending time playing your favorite computer game. And what is happening is that, well, imagine you're learning the gameplay rules of any computer game, just like that. Just like you're learning how to play Tetris, how to play Match 3 and 1, you will just learn quantum computing, simply through playing, simply through discovering these rules, interacting with them. And if you want to know some mathematics, there is a button for that. If you want to create code, to see the code and run the code on IBM's quantum computers or any other quantum computer, anything that supports OpenCASP or Qiskit, then you can take the puzzles and the visual graphs you create in Quantum Odyssey, and you can click another button and you will get the code out that you can upload to your hardware of choice. So without any further ado, let me start with something boring because I'm considering to show you a bit about the mathematics behind it. So the first thing you'll see in Quantum Odyssey, and we'll go through Quantum Odyssey, so don't worry. The first thing you'll see is colors. Colors because in quantum computation, you're not working with integer numbers anymore. You're working with complex numbers. Complex numbers require a 3D grid to be described, right? And we've represented this 3D grid through colors. How? I will show you right now. So if you're just looking at simple quantum gates, I'm sure everybody here has seen a NOT gate or a poly X gate, 0, 1, 0. This is how it will look in Quantum Odyssey. Very simple, very straightforward. And you can imagine if your input state would be 1, it would become 0 again, right? Because, well, the game shows you the full Hilbert space of your state vector and the algorithm that you will be designing. So for a Y gate, what you will notice as a difference is that instead of ones, you will now have -I and I. As you know, complex numbers are of the form of A plus IB. So representing the real part or the imaginary part has its own properties. So the real part is represented through blue and red, and the imaginary part is represented through green and gold. And you have -I here because you see you're coming from the one state, which means this term will apply. That's why you have the gold color here, and the I without the negative phase, because, well, it's coming from the zero state. So all these things will start to make sense once you start playing with Quantum Odyssey. So basically, you will learn quantum computing through a pure visual form. It's as if saying, yeah, so just through engaging with these visuals, you'll realize a few things. First, linear algebra has some really cool patterns in it. So this is the Hadamard gate. Yeah. And you can see inside the Hadamard, you can see how the ball splits. So if you come from the zero state, you get a 0 and 1. And if you come from the one state, or well, here in this case, you have an X gate, then you have a H gate. So you're coming from this direction and going from here, you will see this phase applied. This is another interesting thing. I don't know if you guys have been to Q World and so on. Maybe you've seen Quantum Odyssey shown there as well. Explaining kickback phase is quite counterintuitive. So you cannot tell anybody using just plain words without referring to something like this, like a visual, the effect of the kickback phase. And for example, in this case, yeah, because information is always preserved according to the law of thermodynamics, of course, you would expect that all quantum computation should be reversible and information should always be reserved. So if you would imagine flipping a coin, you will never get a situation like this, like getting yeah, you would either get 0 or 1, right? But if you have a Hadamard gate, which would be similar to saying I'm flipping a quantum coin, then you will always notice the differences, right? Because here you have two balls color blue, here you have a blue and a red ball. Yeah, just because it acts the extra phase on the state one. So then entanglement, and the list keeps on going, right? So you can do, this is a Bell state, fully represented visually. Then Grover. So there is no limit, literally. You can do wherever you can think of in Quantum Odyssey. And you will be able to learn all of these and develop your quantum intuition. We are the first who coined the idea of quantum literacy, at least so that's what people say. And yeah, Quantum Odyssey is based on the principles of quantum literacy. By that, I mean quantum computing should be accessible and easy for everybody. There should be no barriers to entry. And there should be as least misconception as possible in the field. So if you're mastering Quantum Odyssey, if you're just engaging with it for like 10 hours, you should be able by the end to look at research papers, to look at what people say about entanglement, about superposition, about quantum interference, constructive, destructive interference, and you could make with your own mind, yeah, if what you're seeing is actually it's true to the science or not. Yeah, at least that should be a minimum step from which I hope you guys will be left after playing with Quantum Odyssey. And now, to play with Quantum Odyssey is very straightforward. I will paste you the link in the chat just in case you have skipped the email, and then you'll get this installer. This installer requires some username and password. Everything you do is connected to our servers because we are doing learning research. So we want to know how you're progressing and how to optimize better the paths of learning and how hard the puzzles are. Some could be quite difficult. So we are trying to always make the learning curve not be as steep as much as we can. Ideally, just log in with one of these buttons, unless you have some, unless you want to create your email. Your user account. So after using like Google login or Yahoo login or something, then you should just be able to install in the launcher and hit the play button. Yeah. So no more complicated steps. I know I sent to Vardaan quite a big list of things that need to be done. Now it's no longer necessary. Yeah, there is here a button to send you to our Steam page. This is our Steam page. And why Steam? Because, well, finally we've received the funding. So this gonna be released on Steam, you know, let's say 5 times what you see currently in Quantum Academia version. So this next version that's gonna be on Steam, it will be, I think, by far the best game ever made in quantum computing on Steam. I really hoping so. I don't think there is any contest right now. So yeah, it will have a full story. It will have characters, very engaging. You will learn about cosmology, particle phenomenology. You learn about fermions and bosons. Maybe you'll even interact with AIs that will act as tutors in game. So yeah, we have high hopes. You will really love what's coming next. So besides that, what you will be engaging in, it's just the most important, it's too loud. What you will be engaging in Womanium is this. I would highly recommend for you to start with chapter 1. You might think bit flips is easy. If you understand the basics of complex numbers, then you could go to colorful flips. But these are important for you to get adjusted with how quantum Odyssey works. And then slowly traverse your way. You will learn about GAZ states, W states, quantum teleportation algorithm, swap gates, basis transforms. You will see how computation based in the 3 bases, I mean measurement in 3 bases, is actually or can be understood through the visuals in quantum Odyssey, and understand what doing a basis transform is all about. Why a Z gate in the Z axis is not doing anything, stuff like that you'll be learning. Then you'll be going towards global search, and this is an important module. I really hope most of you can finish this module. This will teach you how to port a real world problem on a quantum computer. This, through quantum Odyssey, we are actually trying to tackle one of the big problems in how quantum education is today. Everybody's learning about algorithms. Everybody's learning how this algorithm does something magical. Yeah, but I haven't seen many resources that actually teach you how to construct an algorithm, how you should build it, building block by building block, build an algorithm, or understand how to optimize an algorithm. So this is more or less what quantum Odyssey does best. And what I would like the most is to see you here in the leaderboard. Yeah, so can you be first place? Let's find out. Always you can access leaderboard here. You can see your friends, your buddies, and you can find out where you are compared to them. Here in the My Challenges section, so in the editor, this is a sandbox where you can create whatever you want. But here you can create a challenge, give a name, and then send the challenge ID to your friends and ask them if they can solve your problems or your puzzles. Yeah, so you can create some really cool challenges between yourselves and try to see if your friends can solve that. So yeah, a lot of interesting visuals that I will let you to discover what they do. You'll always have access to the math layout, to your tensor products. They'll always be here waiting for you if you love the mathematics. Here you have the option to save this as a gate and compile the whole circuit in a single gate. It's again something quite new and interesting for people who are into quantum simulators. So this gate at the bottom does all of this combined, right? All sorts of magical things you can do. You can flip this gate. There's a million secret features hidden in between these things. And if you want to simulate this on QSkid, just select the number of shots, click this button from IBM-Q, run the QSkid simulation, you'll get some results. Well, not in this case, but later, and then you'll be able to save it as a circuit. And you can run it on any kind of Jupyter notebook. It will be completely compiled, including the call functions from the start. So yeah, in a nutshell, this is what quantum Odyssey is all about. Visual simulator through which you can create absolutely anything that can be done on the umbrella of linear algebra, of unitary matrices, part of the SO2 group, literally everything that defines universal quantum computation. Now, I hope you guys will enjoy this, go through all the steps, try to finish the whole content, and come to our Discord channel and let us know what you think. And I will put the link in the chat room. Okay, so let me stop the screen share and throw the link. We also might have a Mac version, but I think it's a bit unpolished, and I don't know if you need the Mac version. Ideally, would be for you to run it, run the simulator Windows operating system and run it there to have the full experience. I would not want to send you the Mac version at this stage. So unless you really want a Mac version, I can, but otherwise, please just use the Windows version. Any questions? Anything that comes to mind, let me know.
Yeah, thanks a lot, Laura, for your wonderful demo. I am going through the Discord chat and I'm receiving a lot of messages more on the positive end. They are very excited and yeah, ready to start the gaming sessions on their own. One question I would like to start this discussion is, knowing a little bit more about you on the personal end, right? What motivated you to develop a quantum game, and what was your journey like? So if you could share a little bit more details on that with us.
Yeah, I have quite a power. Sorry, I'm a bit cold. I have a powerful inception story in the sense I came from a background finishing computer engineering for masters and working for about 10 years in the IT industry in AI and such. I went to, well, I kind of got accepted for a PhD in quantum computing. And when I realized what I'm gonna learn, I kind of fell off my feet, right? Because all I wanted is to understand how to build quantum algorithms, right? Why am I learning about particle phenomenology now? Why do I need now to know how atom interaction goes? Or why do I need to know about operation and annihilation operators? What am I gonna do with all this information? I don't care. I am a computer scientist, and I just want to learn quantum computation and figure out some cool algorithms that can solve some mathematical challenges that I'm actually interested in. So yeah, I literally closed myself in my PhD room, closed the blinds, and spent there, I think, like 6 months prototyping on the whiteboard a complete set of visual cues. That should be enough to fully represent one-to-one rigor without anything else that needs to be added. Everything that you can do using the universal gate model set. So using pure linear algebraic tensor products, chronicle products, multiplication rules, and so on. And this is how Quantum Odyssey prototype was born. I have my inception story posted on LinkedIn. If you guys want to go there, I spent 5 years doing this, and at the beginning it was made in Paint, right? And now it looks like a proper project. So yeah, I'm quite happy. It's been 5 years, amazing years. It's got a ton of features. It's gonna be like the Adobe Photoshop, but for quantum algorithms, we hope. But yeah.
Yeah, I totally understand. It's been an amazing ride, and seeing the game now as it is, I think it's an amazing platform for everyone to jump in, see how they can learn new stuff. Another question, which is, asked quite a few times in the Discord chat now, is what was the platform used for developing this game? Was it using Pygame? Was it Python-based? If you could, share some insights onto that.
Yeah, so this is a combination of C#, Java, JavaScript, Python, and SQL. We also kind of we worked with people because we used Unity engine to make the graphic assets to pull everything together, right? So we had to upload new DLLs for the Unity team because they had no support for doing the type of matrices we would plan to do with using complex numbers, right? So a lot of back and forward and a lot of interesting technical challenges to make a quantum simulator that can show you in real time what's happening when you place a gate. So that was that's the answer. I mean, a lot of different things.
Yeah, so if perhaps some of the early stage students are interested in game development and want to use their skill sets for quantum game development, are there any opportunities where they can directly work with you? Are there positions open at Quarks Interactive, or they can perhaps contribute towards open source development? Is there any opportunity like that?
We were getting this question quite often. Now that we are crunching our asses, I mean, we have about, we hope, it's not official yet, but we really hope in 4 months the game will be ready for Steam. And the Steam community, if they see a bug, they will murder you in public. So we had some amazing people who wanted to work with us, but we cannot because our team is composed of 4 developers that are non-stop working and thinking about this thing. And we cannot train anybody. We cannot explain the code to anybody right now. But after the launch, there's going to be a ton of patches necessary. I'm pretty sure about it. And then we are open for hiring. So yeah, just contact me on LinkedIn. Contact me through the contact form on my website. Let me send you the site here just in case. And send me your resume and maybe there is something open. Yeah.
Amazing. Yeah. And to all those who are interested, even remotely interested in Quarks Interactive, I was just going to the Steam page, liking it, wish listing it, so that you are always updated on whatever new things Lauren and his team are building on. A little bit more on the technical end and how to formulate the quantum journey moving forward. There are a few questions on what all can students expect to learn from quantum Odyssey. Like you mentioned, Grover's algorithm. Can students learn all the algorithms, or is there a limit to which the current platform allows them to extend the quantum journey?
You can look at any science paper and do the proof of concept algorithm, any kind of proof of concept algorithm that, well, you can only do it up to 5 qubits in quantum Odyssey because the Hilbert space grows dramatically, right? So 2n+1, and there you go. So only 2 to the 5, and you can do absolutely any sort of unit algebraic function there. You can use trigonometric functions, you can do whatever. But most importantly, I think, is to just be patient, start exploring the first 3-4 modules in quantum Odyssey, and then you will think of new ideas. Yeah, and I honestly think it's not about learning algorithm. Learning quantum computing shouldn't be about learning algorithm. You know, some people have discovered some algorithm. Why are we learning these algorithms? We should be learning how to do quantum computation. Yeah, learning how to think about computation and how have this mindset that, look, I can now understand how I could port a real problem on a quantum computer. Oh my God, I have to rethink everything. I have to come up with some new ideas. I have to create my matrices, how they should be created. It depends on the hardware. Stuff like that we are teaching, more than the algorithms that people make.
Great. Yeah, a couple of final questions to wrap up today's discussion. And this is more about how can we invite our friends to use this platform, and more on the academic side too. There are certain professors in the chat too who would like to include Quarks Interactive as a part of their curriculum at the universities. So 2 questions. Number 1, how can they invite their friends to start playing along with them on this platform? Number 2, are there bulk licenses for Quarks Interactive to include in the academic side too?
Vardaan, this is a very good question, and I don't have an answer for it yet. We are putting all our effort into R&D and production. We don't have a monetization strategy properly figured out, but what's happening is just this month we had 3 universities that contacted us and bought licenses, and all you guys on the chat are receiving that license for free. So ideally would be if you can write on the contact form for Quarks Interactive, because I'm just the founder, but there are lots of investors who have helped us to get here, and we can negotiate a deal. That would be best. If you have to share it, I like you guys, so I'm also sharing things. So yeah, I mean, but if it's something official, if you want to run an event, something like that would be amazing, because we are a small startup and we really need funding. Through Womanium, we haven't received funding, but we do need funding to survive and grow. Yeah.
Wonderful. Another last question I would, just wrap it up after this. There's a lot of there's a lot of interest in supporting the game in general as well. So people are interested, how can they contribute towards the game? It could be in different ways. So what do you suggest are the next steps for people who are interested in contributing towards the game?
That's amazing as a question, because we are considering creating something as something I like to call, I don't know if people will agree with me, in academia, because it sounds a bit too cliche, markety, Quantum Ambassadors program. So if you are able to create YouTube videos using Quantum Odyssey, direct people to buy Quantum Odyssey, to try it, to test it, anything in this direction, please let us know if you're able to do this. If you're an influencer, if you're someone who can do stuff like that, then please do let us know, and we will try together to work out this kind of Quantum Ambassador program, kind of like make sure people who are bringing information about quantum to the world get rewarded as we get rewarded, as we are making this easier and nicer for everybody. So we are trying to create this community around Quantum Odyssey. Yeah.
Amazing, amazing. Yeah, so as Laura rightly mentioned, next steps, do try the platform on your own, try out different games, challenge your friends, do challenges, and post everything on social media, right? Post it on a Discord chat. We would love to see snapshots of you playing the game, but also on LinkedIn, on Facebook, on YouTube, make tutorial videos, go wild with it. And yeah, please keep us updated with whatever fun stuff you are doing. We would love to see what all you can do with Quarks Interactive and Quantum Odyssey. So with that, I would like to thank you a lot, Laura, for taking out the time and doing this session with us. And with this, we can perhaps take a quick 5 minutes break before we move to the next session. Thank you once again, Laura, and to all the participants. Keep your questions going. Laura is also on Discord, so you can tackle those questions right away. And then we'll move on to the next session with Gibran and Gibran.